Hey, yo, welcome to my channel. In today's data-driven world, organizations are collecting more data than ever before. Um, but how do you store, manage, and analyze all this data? Um, in this video, I'll explore three key concepts. The data lake, the delta lake, and a data lakehouse. I'll discuss the differences, some of the use cases for each one, pros and cons for each one as well too, and help you understand. Well, I don't want to say understand, but at least help you guide you to what an approach might you use for your need that best fits your needs. Um, so with the lake house, it's like with the data lake. Think about it this way: it's imagine it more so like an open reservoir. Um, that's a data lake. It could hold any kind of data, regardless of the format. It's definitely a cost-effective way to store massive data sets. It can store any kind of data, uh, whether it be structured data such as tables, CSV, or limited files, or unstructured data like text, clear form text, like documents and such, images, audio, whatever it may be. This flexibility makes it ideal for like data ingestion. Um, Now, data ingestion, allows you to dump anything and everything in from sensor data to social media data feeds to actual documentation documents. Another place for the data lake, which is ideal, is basically exploratory analytics. Data scientists can freely explore trends without needing a predefined structure. Then, of course, there's log management. It stores and analyzes application and server logs for you to troubleshoot. I mean, it's great for troubleshooting in that aspect if you have to find out what's going on and such. And then, of course, there's data archiving, where you want to keep historical records of all your data for future analysis. Nowadays, uh, storage is so cheap that you might as well just store everything in the data lake. Uh, Whereas in the past, when storage wasn't as cheap, sometimes you would have to be selective in the data or data point attributes that you want to keep. And then, of course, there's compliance, where you store data for regulatory compliance purposes. Now, data lakes offer several advantages. They're basically highly scalable, meaning you can easily add storage as your data grows. Um, it's more of a case where it's definitely cost effective, put it that way. Um, it's also flexible. I mean, you're able to store any type of data, and structured or unstructured, as we discussed as well too. And basically, you can store anything from that aspect. And then, of course, there's the openness of it, basically, and it's because it's open source, or you're not locked into a specific vendor's tool set. Basically, I mean, think of a data lake where you'll probably say like, hey, what about Snowflake, Databricks, Synapse, what's now Fabric, Redshift, etc. I mean, reality is you're really storing it all still in their storage environments, whether it be S3 buckets, Google File Storage, even your own storage for that matter. Now, of course, there are some drawbacks as well too. So, like one of the aspects is basically that um, data quality can be an issue. The data may be dirty, inconsistent, requiring cleaning before analysis. Another aspect as well too is the lack of schema. It can make it difficult to search and analyze data efficiently. Um, and with it, it's without that proper structure, it's kind of tricky to identify or look for or look up that data from that perspective, unless you create a key value store or some lookup value on outside of it. And then, of course, then the other aspect is which the when you have large data repositories, robust security measures are a big aspect that are essential to prevent breaches. And it's one of those things where you have to put the safeguards in place from that perspective. Now, of course, with the Delta Lake, which is something that I think those that are not familiar with, is more of like a sophisticated layer it sits on top of your data lake. Um, Now, a Delta Lake is relatively new to the point where Databricks came up with it on their own. They have their own format of a Delta Lake. with Delta tables and such. So it's one of those things where Databricks has it, but now it's starting to come in where you have Iceberg, which and Hootie. That's also other aspects that consider that as more of an aspect of within the data lake, Delta Lake as well too. Now, one of the things is with the Delta Lake, it adds features like ACID transactions, which guarantees data integrity and prevents data corruption. It's also performant, basically to the point where um, it's optimized for fast reads, writes, updates, enabling efficient data and processing. Um, this makes your data lake more reliable from that aspect and easy to work with as well too. Um, and with the aspect of that, well, the reliability part for the asset aspect, but performance provides you that aspect as well too, to basically, because it's more reliable and easy to work with, you can also do some data versioning with it as well too, and aspects of doing rollbacks, and some aspects of real-time analytics for near real-time insights and seamless integration with machine learning pipelines. And one of the aspects is like you get that defines into the schema enforced uh, perspective, where you can define and enforce a schema for better data quality and easier data analysis. Now, some of the use cases, of course, for a Delta Lake is, of course, machine learning, which is one of the biggest things that nowadays people are using, where you're training and running powerful machine learning models directly on Delta Lake tables. Then another perspective is real-time analytics, where you can build pipelines for streaming data ingestion and analysis for near real-time insights. Data warehousing is the biggest factor now, more than anything else, where you can create reliable data warehouses within your data lake for structured data analysis. And then there's data versioning. It tracks the changes for the data to for the rollback, as well as basically it's to track the data. So when you need to roll back to a different previous version, that's given that possibility from that perspective. And then of course it's good for, well, not good for, but some of the use cases for a Delta Lake is batch processing, where you want to run large scale data processing jobs efficiently on your Delta Lake tables. Now, one of the Delta Lakes offers several benefits, but some of them are like reliability, where you have ACID transactions that ensure your data is always consistent and accurate. Performance, where it's optimized for faster data access and manipulation compared to traditional data lakes. And then you got schema enforcement, of course, which improves data quality and simplifies querying by defining data structures. Now, some of the drawbacks, of course, are vendor lock-in. While it's open source, Delta Lake still works mostly in the Databricks world, where it's for the Apache Spark Apache Spark ecosystem. So sometimes it's not as straightforward to read data off of it in the Delta Lake world, unless you're working through the Databricks engine itself, basically. And then, of course, there's the complexity part of it as well, too, which setting up and managing Delta Lake requires a lot of expertise. If you are not familiar with it, the learning curve is pretty high or long, so it does take a while to essentially understand and work with it. And then, of course, there's the cost, too, which, depending on which cloud platform you're using, storing the data in a Delta Lake format, it might incur some additional charges. Azure Databricks versus AWS Databricks, there is some cost differential, specifically when you're storing the meta information for those changed data captures between the two. It plays a huge factor from that perspective. And when I'm talking about change data capture, that's where you're storing the transactional data, but also the versioning parts of it as well too that you need. Now you got a data lake house. Imagine a data lake house as sort of a modern mansion built on the foundation of the spacious warehouses that you have. Now it inherits the vast storage capacity of the data lake, but allows you to store any kind of data, from sensor data readings to social media posts to any of the unstructured data that you needed as well too, that's stored in that aspects. But it goes beyond storing just that data. The data lakehouse incorporates elements of a data warehouse, where you're enabling to define how your data is structured into sort of a schema, like sort of where that unstructured data is sort of being cleansed out or transformed into a structured aspect so that you can enforce data quality rules. This makes your data more reliable and easier to analyze, bridging the gap between the flexibility of a data lake and the organization of a data warehouse. Now, you've got the data lake roots, which is basically a data lake house, which inherits the ability to store any type of data, unstructured, semi-structured, and unstructured, of course. This is ideal for organizations collecting diverse data streams from sensor readings again to social media feeds to even um, voice, voice data, voice files from that perspective. Then there's also the case of the data warehouse structure, as I explained earlier, where you got the data warehouse goes beyond just storing the data. It incorporates elements of the data warehouse, allowing you to define schemas, which is a data structure in this case, and then enforce your data quality rules. And this makes your data more reliable and easier to analyze. Um, you've got the unified platform as well too. Like so, unlike the traditional setups with separate data lakes and warehouses, um, the data lake offers a single platform for all your data. This simplifies the data a little bit more to where it eliminates the data silos that you're creating and sort of forces that collaboration that you need between your data scientists, your business analysts, and data engineers and data analysts for that matter too. I mean, the data lake offers a wide range of use cases for all for all the organizations of all sizes. And now a lot of people are moving towards the data lake house effect more so than away from the delta lake, where it offers that unified data platform, centralizing all your data storage management needs. This simplifies the data workflows as well as eliminates the need to manage separate data lakes and warehouses. Um, the Lakehouse also empowers advanced analytics. Data scientists can leverage the platform for various activities. One of the aspects is like from an exploratory analytics to, let's say, building and deploying production ready machine learning models. Um, Additionally, data lakehouses promote data democratization by making data accessible, both data scientists and business analysts. This fosters collaboration and allows business users to explore trends and make data driven decisions um, within that organization. And of course, as I mentioned earlier, basically you have the machine learning integration, which integrates the machine learning pipelines into your workflows and data driven insights. Um, there's the other aspect as well, as which business intelligence. Now, the business intelligence supports the traditional, it supports the traditional BI aspect of things for visualizations as well as reporting, but it allows you to make some more informed decisions based on some of the real time insights that you need, or in insights that you need, or trends that you see within the data itself. And then, of course, there's the other aspects of the real time analytics, which basically builds the pipelines for, you can build pipelines for streaming data ingestion and analysis, and enables like near real time insights for critical decision making, or yeah, kind of a DSS environment from that perspective. And then, of course, the other aspect as well too is like with the lake into the lake house, it still allows you to create a data archiving perspective where you can maintain a historical record of all your data for future analysis and compliance standards. Now, of course, with the lake house, it does offer several advantages. It does provide flexibility of a data lake, allowing you to store any type of data. But unlike traditional data lakes, they offer the structure and governance of a data warehouse as well too. This means that you can define how your data is organized, schema, and enforce data quality rules. It combines the approach and creates a sort of unified platform for all your data, eliminating data silos that can hinder, collaborate, and insights on from that perspective. Um, with all your data too, in one place, the data lakehouse empowers advanced analytics across the organization, from exploratory data analysis to production-ready machine learning models. The lakehouse provides a foundation for those data-driven decision making algos, or actually more so, provides that foundation basically for your data driven decision making processes within the organization or within the department for that matter as well too. Now, another aspect as well too is it does provide enforcing data quality rules, which ensures the data to be consistent and reliable, leading to more accurate and trustworthy analysis. Now, some of the drawbacks, of course, are the complexity, where it's like setting up and managing a data lakehouse requires careful planning. You need to go into that aspect of it because it's not something you just throw up and like put in place and put tables on top of it. It's more of you need to understand the data architecture and management of this data and realize that how it should expand out to you, what you need to from that perspective. And then, of course, there's the cost where it can be more expensive than a traditional data lake, where you're adding additional infrastructure, resources, and potentially cloud storages for charges for the Delta Lake format, which is common in a data lakehouse storage option. The other aspect as well too is you can have the medallion architecture where you have your raw, transform, and curated layer, and sometimes with the raw layer, it's not duplicating, but you are duplicating parts of the data as you're creating that curation layer from that perspective. And then another big aspect as well too is the lakehouse is still an evolving technology. It's a relatively new architecture, and best practices are still coming to play. Like Microsoft, Google, AWS, there and others are coming out with their own best practices. Most of them are going towards the route of the medallion route, more medallion architecture more than anything else. And I don't know if that's the right approach, basically, but it's one of those things where it's hard to define from that perspective of what you think is the best alternative, quite honestly. Now, I'm hoping that this kind of gives you some insights between the difference between a lake house, data lake, and delta lake. Now, you could go for whatever is best suits your needs. Now, you might say like, hey, what about the lake house and the aspect of like, does Databricks support that? Yes, now it's more of a case where like, it does support it from that perspective, but it's a question of how you utilize it versus creating the lakehouse architecture and going from that proper architecture that you're defining. Um, More so, everything else, everyone is basically creating a data lake, just throwing the data in there, and then let's build a lake house on top of that, basically, or creating that unified platform for the data lake with the Delta Lake, because a lot of people were using the data lake and then throwing into data warehouses themselves, but now you might as well have the data lake house, which is where the case of like Snowflake, Synapse, Redshift, GCP, BigQuery, and Bigtable are coming into play, as well as other players as well too, like MotherDuck or DuckDB, sorry, Yugabyte, etc. basically, or CockroachDB. And then there's the other aspect as well too, is with the Delta Lake. That's where Databricks comes in. But now a lot of people are working with Hootie as well, or integrating Hootie or Iceberg into theirs, because Delta Lakes, the Delta Lake format is still sort of more so in the Databricks world, but Iceberg and Hootie sort of support that with Snowflake, Snowflake, Synapse, which is now going to be Fabric soon, as well as other engines that are going to be using that from that perspective. So long as you have the storage capacity to store it. So, I mean, honestly, some people would say, oh, well, you might as well have the Lakehouse in either S3, on top of S3, or on top of Azure Storage or Google's file storage. Reality is, you can create this also in your on-prem environment. The only problem is like that elasticity is not there for you, but if you can create the machines very quickly and then provide the necessary frameworks, you can have the Lakehouse on top of that as well too. The only thing is you wouldn't be able to use Snowflake or any of the other cloud-centric, data engines to be utilized inside those on-prem environments. And that's where DuckDB and sometimes even Postgres, there are some extensions that get into that aspect as well too, as well as Yugabyte, CockroachDB work into that play from that perspective. But I'll leave it at that. Let me know your thoughts, any questions or comments. Let me know, put it in the comment section. I do read my comments and I do respond to them. And I also say that with this, if you like my content, like my video, like my channel, please subscribe if you haven't subscribed. I am trying to build this channel to be more technical based, whether it be tech reviews, but more so tech related more than anything else. But with that, I'll leave it at that. Until next time.